Okay, I guess welcome everyone to this session on software and environments. So this is a pretty broad topic. Like software can include pretty much any software that you can think of. Um, so I'll try to focus this talk on like what are environments and how to make them reproducible. And effectively, we have software in the title because environments affect the way we run software. So let me go to the next slide. Yeah. So the basic outline will be that I'll first give a brief description of what I mean by environments and then go over to some various examples in different languages with a summary in the end. So if you were to define software environments, you could probably find some broad definitions. We'll just stick to this idea that an environment is the system in which your program runs. So this includes both the hardware specs, like your CPUs and GPUs, and it can also include the software details, like what libraries you have access to, or what dependencies, what compilers, etc., that you have access to. So in this presentation, I'll try to focus only on these software details, because when you're coming to the HPC, the hardware part is kind of uh, in the is kind of behind the screens. You don't need to know the full details of the hardware. You need to know like what's the number of cores and stuff, but not necessarily like which cores exactly those are for most cases. But the software details are is really important because it really affects the way your code actually executes. So that's the part that I'll try to focus mostly. There are different types of software environments, and if you're actual software developer, you will see all these different terms being used. Uh, Particularly for us, not all of them are equally relevant. I think the most important ones would be the first one, which is called local development. That is when you are actually building uh, your code, and then maybe you're testing it, and finally you are doing your actual runs on the cluster which you're going to publish. So that is what we are probably mostly concerned with in HPC, and since you're not doing professional software development. But in this presentation, I'll also not really differentiate between all of them. Um, I'll use a very simplified notion of what I mean by environment for this context. So what does it mean in this context, right? So effectively, what I mean by environment is the variables that this command called print env will print out if you run that on a cluster. So as you can see in this example below, that when I run print env on the Puma, it prints out various variables and their values. Now, it's a really big list, and I've just shown like the top uh, 5 or 6 of those. But it defines multiple different values. For example, I have this value called X disk, which defines a particular location that I can access. So these variables will typically define the environment in which your code will execute. So these are not the variables that you define in your code, right? So say in your code you have some number x equal to 10, and then you have some p equal to x times 2, but those are not what I mean by environment variables, it is the variables that will affect the way your code runs. So if you want to access this location X disk and you use this variable X disk, then it needs to be defined before you can access that. So that is what I mean by environment here, and we're going to see how that affects the way your program executes. So if you like so like if you were to define these variables, like you can define them in your bash RC, which is the most common place where people define most environment variables. Sometimes they can be defined in other files, which the bash RC will load. And this is something a common issue that crops up from time to time, that people don't check that their bash RC are loading different files in which there can be some environment variables defined, and they're unaware of those variables, and it affects the way the code executes. You can also interactively define them in the shell. So you can run this command, say export abc equal to some number, and that will define a variable abc in the shell. It can also be defined by a module. So for example, if I were to run a print env and search for this AlphaFold variable, it would not show me anything. But if I load the AlphaFold module and then do the same thing, now I can see that there are two variables that can contain this term AlphaFold in them. So when I load the module, it changes the environment by defining some variables. So that is a third way that variables can be defined. You might even define some variables in your batch script, and but these are probably the most common places where you will define uh, environment variables. So up to now, what I discussed, I kind of captures the basic idea of what I mean by environment. If there are questions on this, please let me know. And I guess you can also type in the chat. I should be able to see that. So now that we have some idea about environments, let's discuss what are virtual environments. So virtual environments I, I isolate the dependencies and libraries of projects from the global environment. So when you log on into the HPC, you land into a global environment. And let's say your global environment gives you access to some libraries A and B with some particular versions. But now you are doing some project in which you need different libraries, or those libraries with different versions. So the thing you can do is you can create a virtual environment and install those particular versions or those particular libraries in that virtual environment. So the libraries that you install in the virtual environment will not be able to be accessed from outside. So you can only access them from within the virtual environment. So in that way, it is I, I, isolating the dependencies uh, from the outside environment. So if you look in this picture, I have got two virtual environments. In the first one, I have libraries A and C with some versions, and in the second one, I've got libraries B and D with some different versions. So this virtual environment will not be able to access the libraries A and C from the other one, and similarly, uh, this one will not be able to access the libraries B and D from this one. And likewise, the external environment will not be able to access any of those libraries from those virtual environments. Now, maximum languages that we encounter usually have some tools to create virtual environments like Python, uh, or they have some build systems that takes care of those dependencies like C or Java. So, uh, and there are also like tools like Conda, which can manage virtual environments. So my suggestion to you would be that if you're using things like Python or R, then try to use virtual environments if you can, because they ensure that your libraries and dependencies don't conflict with others. Okay, I see there's a possible question in the chat. Okay. So make sure I have this correct. When using Python, a virtual environment is different than a conda environment, or is a conda environment, or is a conda environment a virtual environment? Yeah, so I will come to that. But to answer your question, conda environment is a virtual environment. But when it comes to Python, there are two types of virtual environment. One is built into Python, and one you can make it conda, and they are not the same thing. But I will come to that in more details afterwards. Okay, so now we'll see the first example now in Python. Okay, so in Python, there are multiple ways to create virtual environments. One with Vemp, which is the built-in Python tool, and then you have Conda. And I'll go into the details of Conda afterwards. For now, I will just talk about Vemp. Okay, so if you want to create a virtual environment, you can just simply do this with Python 3 -m when, and then name of the virtual environment. So in this case, I use .when. You can give a name that whatever name you would like to. So the main thing it will do is it will create the virtual environment in a subdirectory of the name that you provide. So if you were to provide a different name, then the name will be different. But in this case, it will create a subdirectory with the name v and v with a dot in front. And if you want to try this, you can run this thing directly on the cluster. I can try to show this thing maybe towards the end. If there's time, but you are welcome to try these commands and see that they actually create the virtual environment with that. And we do have plenty of info on that in our docs. So if you'd like to use the Vemp tool, definitely check the Python section in our docs. I think it'll answer plenty of questions that you might have when you're trying to use this. So after you have made the virtual environment, if you want to use that, you first need to activate that. So before I activate the virtual environment, if I just check the Python 3, like the location of the Python 3, then it will show me the default system Python 3 that the Python 3 module gives me. And then after I activate the vent, and you can do it with this command that source dot ven slash bin slash activate. So if your virtual environment name was something else than dot ven, then you can change that. But after that, it will be just bin activate. And after you do it, you will see that the prompt will show the name of the virtual environment. So it will show .ven, and then if you check the Python 3, it will show that it is coming from that virtual environment. So now you can see that the virtual environment is actually active, and it is and you are using the Python in the virtual environment and not the Python in the global environment. And after you activate that, you can install your packages. So you can do pip install numpy, and you will see that it will install the numpy in that. And after you are done with your code, you can simply deactivate that with this command called deactivate. And once you do that, you can see that the virtual environment is not active because it's not there in front of my name. So that's extremely simple. So just build a virtual environment, activate that, install your the system, sorry, install the libraries that you like to, and after you are done with your code, you can simply deactivate that. So that's the basic use of Python virtual um, of Python virtual environments. And like I was saying, you can check the Python section uh, in our docs, and that should give you more info on this. So are there any questions on building or using Python environments based on this so far? Okay, if there are no questions on this, I'll move on. So some things that you should keep in mind is that you can create multiple virtual environments under the same parent directory. And this can be useful if you want to test multiple different versions of the same software, or say different implementations of your code. Then instead of building a separate project for every single version, you can just keep them all in the same place, and you can test your code. But you should be very careful during your actual uh, runs, because you need to choose the correct, or like activate the correct virtual environment when you do that. And the second thing is you can have only a single virtual environment at active at a time, right? So let's say I make a second virtual environment in the same place. So I do Python 3 minus when dot when2. And now first I activate my first one. So I get dot envier, and then I activate dot when2. And you can see that now it has moved to dot when2. And since I did not install NumPy in dot when2, if I try to import that, it will show that there is no NumPy in that particular virtual environment. Environment. So I did install NumPy in the first one, but it did not do it in the next one. So that's why when I activate the next one, it is not able to import that. Okay. Now there are things that can break. So let's say I first activate my first vent, and then since I have already installed NumPy there, I import NumPy and I try to run this particular NumPy code. So it does np unstack, and you don't need to know what np unstack actually is. It's just an example, and you can see that if I do run this code, this will actually give me some kind of output. Now, oh, sorry. Now I activate the Vent2 and I install NumPy, but at the same time I mention a particular version of NumPy, and it will install that particular version of NumPy. And then if I try to run the same code, it does not run. And that is because this NumPy unstack function was defined after NumPy 2.0. So NumPy 2.0 does not have NumPy unstack function in it, so it will not be able to run that code. So whenever you're doing this, you have to be careful about the versions, because not every version of a library will have the same functions. Okay, there's a question here. Just in case, if we update from Python 3.9 to Python 3.2.12, will the existing environment work, or do we need to reinstall all packages in a new one? You will need to build your new environment and reinstall all the packages. The existing one will not execute with a new version of Python. So you have to do this Python then activate, install, and everything. Okay. Okay, so there are things that can break. So what is the answer to solve them? We can make Python virtual environments reproducible. Now, this is different than something what I said earlier. Let's go back to that. What I said was that you can have multiple virtual environments under the same parent directory, and that is good for testing. So that is when you are testing your code, that you are trying to run the code with different versions of the same library, and you're seeing if it is doing the same thing, or whatever you're trying to see. That is different than trying to do a reproducible build, where you would what in reproducible Python virtual environments is that you would like to have the same packages and the same versions in two different virtual environments. So suppose you build some code, and then your advisor or someone else in your lab is trying to execute that. They need to have the exact same virtual environment that as you. So that's why it is important to be able to make your virtual environments reproducible. So the best way you can do it is by version controlling the dependencies. Okay, so there's a function in pip called pip freeze. So if I do pip freeze minus L, it will make a list of all the packages with their version numbers. So if I do that in .when, I get numpy equal to 2 point this number. So this is the version number of the numpy that is there in .when. As and now I can save the output of pfreeze dash L to a particular file. And when I do that, so I have pfreeze dash L and then this uh, symbol, and that just means that you would like the output of this function to be saved to this particular file, and then I go to .when2, and now I can install from that file. So now I do pip install minus R and that file, and now you can see that it's actually installing the same version of numpy. Okay, so if I were to go back, at first I had installed numpy 2.0, and now with this I'm installing this numpy in that same virtual environment. It is going to update the numpy there to this version. So now uh, both .when and .when2 will be able to run the same code. Okay, so that means this is now a reproducible, that I can reproduce my environment in a different location. Any questions on reproducible virtual environments? And this is important because if you would like to debug your code and you end us a ticket, and I would like to execute your code to see the problem, I should be able to do that in the same environment as you. So it is useful if I can recreate that. Okay, so this is why it's important to be able to do this. So there are two different ways that you can control the versions. So the first is what I just described, that you first make a virtual environment, and then you install packages in that. After that, you do that freeze, and then you can install the packages in other virtual environments from that file, right? And then there's the second route, is that first you actually make that file in which you define all your libraries with their uh, versions, and now you can use this file to install packages in any virtual environments that you would like. So this one does give you more control on the packages that are being installed, but at the same time, it is tough to specify the versions of all packages. I mean, in the example that I just showed, there was just a single NumPy, but maybe your project needs like 20 different dependencies, right? So now to find the virtual numbers for all of them uh, can be a tough thing. Particularly, there can be uh, versions there can be dependencies of those libraries with version with different versions than you would like to have. So there is a third way that makes this easier, and that is you can use this tool called pip tools. So in with pip tools, what you can do is that you first make a virtual environment, and then you install pip tools in that. After that, you tell the versions of some of those packages, and then pip tools give this function called pip compile, which will then find out the correct versions for all the packages that you would uh, need. And then after that, you can use that file to install packages in any virtual in any virtual uh, environment. Okay, so let's see how it actually functions. So let's say I make a .ven 3, and in that I first install pip install pip tools, and then I would like to create an input file, and we can give that any name. In this case, I've given this name, and I in the main thing is that I mention the versions for some. So I mentioned that I want NumPy 2.0, but I did not mention the version of SciPy. So pip compile will figure out a version of SciPy that is compatible with the NumPy version 2.0. So if I do pip compile and then the file name, it will create this file which has both the NumPy version and the SciPy version. And then after that, you can use this file to install your packages. So are there any questions on using pip tools? This might be something new that you have not used earlier, but I would suggest that you do use it to ensure that your virtual environments can be like recreated by someone else. So if you just share the file with the packages and the version numbers, then anyone can recreate that same environment as you. And this will also help you keep track of the libraries and packages that you had installed, so that afterwards, when you're changing or updating your code, you know the library dependencies that are there. I mean, sometimes when you come back to a code, some 10 months later, you have no idea, like, oh no, what this code supposed to do. So this can kind of partially help to keep track track of the changes that you had made. Okay, so if there are no question on using pip tools, let's move on. And now we'll move to R. So the main thing in R is the version clash between different versions of R. So the most important step is that you actually install R into version-specific directories. Now, on the HPC, you don't need to actually install R. So we have already done that for you because we have the modules and they are all in their respected, in their respective directories. So you will not see any version clash on base R. But the main issue is that if you were to install different packages, and if you don't install them in version specific directories, then you still end up with the same problem. Okay, so main thing is that don't mix packages meant for different R versions. So let's say I'm trying to install this package called RENV, and I am using R 4.2.2. And when I try to install that, it will give me this path to install. Like this is the place where the package will be actually installed, and you can see that there is the uh, version number 4.2. So this is fine. But suppose if you were to choose a path which did not have that version number, then that can cause problems afterwards if you were to use a different version of R. Okay, so when you're installing packages in R, choose a version specific directory to install them. Now, in Python, we just saw virtual environments in Python. You can do something similar, but maybe not exactly the same with this thing called .r environ files. So if you'd like to define a .r environ files, you can do them in your in your projects or in your global environment. Okay, so you can define a file in your home, or they can be in each project. Like in this picture, I have a .r environment for the first one, but not for this second one. So R will always prioritize the .r environment file in the project than the one in your home. So in this way you can specify the virtual environment for a particular project. Now, if you like to, I mean, the easiest thing that you can use an .r environment file for is to specify the location to in, in, install your packages. So if you just put rlibs user equal to this, then each time you try to install a package in R, it will install that in a particular version directory, right? So effectively, if I just go back, if you try to install that, it will try to install in a path like this. So that is an easy way to ensure that your uh, art packages are installed in version specific directories. Okay, and then there's also a package called art env, as I was trying to trying to show that I'm installing that. This is something very similar to pip and venv. So after you install the package, you can use that to install other packages. You can also do something just like pip freeze that you do in Python. In this case, we will use this function called snapshot from this library, and then you can also restore the virtual environment with this function restore. So if you have understood the way I was using I was doing in Python, this is extremely similar to that. So with R, you can choose to use this particular package, or you can use this .r environment files to maintain your virtual environments. So any question on our virtual environments? Okay, not seeing anything on that. So sorry. So let's move to Conda. So first, I'd like to clarify some particular terminology here. So Conda, you probably hear all these terms, Conda, Mamba, and Conda, things like that. So Conda and Mamba are just tools to manage virtual environments and install packages in them. Whereas this one, Anaconda, is actually like is effectively a distribution, which means that it is Conda plus lots of packages plus some access to some of their private repositories and stuff. So this comes with a ton of things already pre-installed, but just Conda or Mamba are just effectively are just two tools uh, uh, to like for that will two tools to make virtual environments and install packages in there. So if you'd like to use Anaconda, you can check our docs for this section. But we are going to update this section like in the coming months. So you might have to change the way you do things if you're following that now. But in the examples that I show below, show after this, I'll use Mamba, which acts just the same way as Conda does. So you can just exchange Mamba with Conda in the examples, and it will run the same way. The main reason I'm showing Mamba here is because we are likely going to change our way of accessing Conda virtual environments, and you will likely be advised to use Mamba. So I just want to demo that, so you have an idea of the things that are coming. Okay, so let's look at Conda virtual environments. And as I was saying earlier, that Conda virtual environments, they behave very similar to Python ones, but they are not the same thing. So don't mix Conda and Python virtual environments. That is, if you have made a virtual environment with Conda, don't make a Python virtual environment inside that. That can, I mean, you can do it, of course, but if you do it, it might be, you might not be able to control the things the way you would like to, and it can be very difficult to figure out the problems there. So don't mix Conda and Python virtual environments. Just try to stick to either Conda or Ven. Okay, so you can just do the same things as you do with Ven. You can do the same thing with Mamba or Conda. So let's say I would like to create a virtual environment. So I just do Mamba, or in this case, or if you want to use Conda, just replace Mamba with that. And then I have this enter command where this is the name. So I do dash n is the name, and I'm just saying that it should install Python 3.11 in that virtual environment. Okay. After that, again, I activate that. So I do Mamba activate the virtual environment, and you can see that it is activated here. After that, if you want to deactivate that, it's the same thing. Now, instead of, so with when you just do deactivate with Conda or Mamba, you would do Mamba deactivate. So that's the main difference there. Now let's talk about how to make these virtual environments reproducible. So you can use pip inside Conda. So if you would like to use pip inside Conda, that's fine. Don't use when inside Conda. Okay, so that's the main difference. You can use pip there, it's fine, but not when. If I just do pip install, and I had made this file earlier when I was when I was doing the Python example. So if I do pip install -r and the file name, you can see it'll install the same version of NumPy in this virtual environment. So just, and because you can use pip, you can use pip freeze just like earlier, and it will and you can do the exact same things that I did discuss earlier in Python. But since Conda can be used for or just Python, but Python, R, and Julia, I mean, it doesn't depend on the language per se. So if you'd like to export all the packages that are installed in your virtual environment, then the best way would be to use this command, mamba env export, and that will um, list all the packages that are installed by Mamba or Conda in there. So if you, but there are some problems with that, and the main thing is it might not list the dependencies that are installed by pip. So let's say in your Conda environment, you install some packages with Mamba, and then you install some packages with pip, right? So when you do Mamba env export, it will export packages installed by Mamba, but not the packages installed by pip. So then you will need to do both Mamba env export and pip freeze. So so it might be better that you actually first that you first manually create the file, this environment.yml file, in which you mention all the dependencies, and then you can create and install packages from that file just with this command called mamba create -f and the file name. So in this file, what I have placed here is just the name of the environment, the channels from which Mamba will install this packages, and then the packages that are to be installed. So I have done Python equal to 3 point this, and then pip, and then this line is saying that after it installs pip, it will use pip to install the install the packages from this file. But there is an option that I could just take this thing out and just replace that with numpy equal to 2.1, because Mamba can install numpy directly. It does not need pip to do that. But if you like to install with pip, then there is the option to do so. Okay, but anyways, the main idea is that you first make this file, and then you can create your virtual environment and install the packages with Mamba create -f. Uh, so that's the basic idea here, and I think we are very close to the end. So I'll actually not go into this example over here. Just go to our summary. So basically, just use virtual environments and don't mix different types of virtual environments, and try to control the version numbers of your packages. So with pfreeze or conda, or with rn, you can control the version numbers of your packages. So try to do that. So that can ensure that your code will run the same way each time. Okay, so that's basically the end of this. If there are questions, I can take those. If not, you are all free to go. Yes, that's